Now see in this question, an object is placed at a distance of 36 centimeter from a convex mirror. Suppose you have got a convex mirror like this, an object is placed at a distance of 36 centimeter, object is somewhere here AB. Now a plane mirror is placed in between so that the two virtual images so formed coincides. So now the plane mirror is placed somewhere here, which is at a distance of 20 centimeter from the object. So this distance is 24 centimeter. And the image obtained by the plane mirror and convex mirror both coincides. But we know that thing, for the plane mirror, object distance is equal to image distance. So obviously the image will be obtained here at a distance of 24 centimeter from the plane mirror. Now we have to, we can get the image distance for the convex mirror. So this image is suppose for the convex mirror as well as for the plane mirror, and its distance from the mirror is, that is here. So we can write this one 36 minus 24, that is 12 centimeter. So image distance for convex mirror is 12 centimeter. So here we have used the concept, the image distance and object distance for the plane mirrors are equal. And for the convex mirror, that is a minus 36 centimeter. So we know the two quantities like V and U. So now we can calculate focal length. So we know the mirror formula 1 upon f equal to 1 upon V plus 1 upon U. So that is 1 upon f is equal to 1 upon 12 minus 1 upon 36. I have used this here the sign convention. Now we can solve. So when we solve this equation, we will be getting like this thing is here 1 upon f is equal to LCM is only 36. So we can write here 3 minus 1. So we can write here 1 upon f is equal to 2 upon 36. So f is equal to 18 centimeter. So if you have got f is equal to 18 centimeter, so now the radius of curvature is twice of focal length. So we can write r is equal to 2f, that is 36 centimeter. So this is the radius of curvature of convex mirror.